Hey. Given a linked list, this is problem number 5. Given a linked list, return the kth node from the end. Okay, so I'll start with the function definition. The way I'm going to solve this is super cool. Even though it's simple, it just blows my mind that, you'll see very shortly. Okay, so given a linked list, an integer k, return the kth node from the end. So, what do I mean? Let's say I have a list. Okay, 1, 2, 3, 4, 5. No. And k is. I want the second node from the end, so not 5, but 4. I will use a node I'll call left, assign it to the head of the list. Right, and essentially I'll send 2 pointers out into the great unknown, and they will give me this information in big O of n time or less. So I'll send out first my right pointer while count is less than k. So I'll send out my right pointer k times. Right is right x. That's what I want. Increment count. And then after I've sent out my right pointer, while the right pointer is not null, so while I'm not at the end of the list, move left and right along. So the reason I'm doing this is, yes, I could just I could just send out a pointer to count how many nodes there are in the list, and then go back and find the kth node from the end, right? By only going out n minus k times. But instead I can do it all in one simple pass through the list. So as I've discussed or alluded to a few times here, the time complexity for this algorithm is big O of n, and the space complexity is constant. I'm not using any auxiliary space here. Okay, let's go through this example. So the list is 1, 2, 3, 4, 5. K is 2, and that's silly. Left, not list. I'll just proofread the rest of things here. Okay, looks good. All right, so left is starting out as 1. Right is starting out as 1. Count starting out as 0. Right, well, count is less than k. True. Right is right dot next. All right is 2. Increment count. Count is now 1. Wow, count is less than k. Yes, 1 is less than 2. Right is right dot next. Okay. Right is now 3. So count is now 2. Count is no longer less than k. We move to this next while loop. While right is not null, left is left dot next. So left is 2, and right is now 4. Moving on, right is still not null. Left is 3, and right is 5. Right is still not null. Moving on. Left is 4. Right is null. So we don't enter this loop again, and we return left, which is 4, which is indeed 1, 2 from the end, just like we said we wanted, with k equals 2.